Now let's start with a new topic, technology, a pervasive factor in logistics fulfillment. After listening to this chapter, you must be able to understand the role of technology in logistics. Second, automatic identification technology. Third, EDI standards, applications and benefits. Fourth, automated material handling system. And fifth, warehouse simulation, satellite tracking, ERP, DRP and AITS. Technology is a means to enhance business competitiveness and performance. It is an enabler to create wealth, which depends on the capability of an organization to adopt technology through the change process and deploy it for integrating business process. Technology has become the key factor in defining the competitive advantage in today's business world. It is playing a major role in success of the supply chain by enhancing the overall effectiveness and efficiency of the logistics system. It has become appallingly obvious that our technology has exceeded our humanity. Now, what are the roles of technology? Technology is playing a major role in the operational effectiveness and efficiency of various functional areas of the management. Information technology helps in real-time information processing and analysis. Due to robotics and automation technologies, repetitive operations can be done with great speed and accuracy. On the communication front, the ease and speed in connectivity across the globe has changed the way transactions are done. As a result, the accuracy, reliability, and speed in material and information flow in the supply chain has increased manifold, leading to productivity, effectiveness, and efficiency in logistics operations today. Many new technologies in logistics are in use in the developed countries, while in India, the adoption process is a bit slower. However, owing to liberalization of the Indian economy, competitive pressure is building up, and the only option for competitiveness is to go in for technology-enabled operations. The latest technologies being used in logistics are in the areas of automatic identification, next is communication, third material handling, and fourth facility design. Let us have a look at the automatic identification technology. Automatic identification, or which is generally abbreviated to auto ID is the term used to describe the direct entry of data or information in the computer system, programmable logic controllers, or any microprocessor controlled device without operating a keyboard. Auto ID includes such technologies as barcoding, radio frequency identification, data communication, magnetic strip, and voice recognition. The usage of these technologies is based on the applications and the benefits derived. Auto ID can be used for tracking rail cars, a carton moving on the conveyor at a speed of 100 feet per minute, or a truck carrying goods on time-bound dispatches to the consumers. The benefits of Auto ID are many, such as accuracy. Error-free data entry is possible and there is no human involvement, hence accuracy is possible. Next is cost saving. Reliable and correct information is made available to reduce the risk element in decision making or resource allocations. The technology also facilitates economies of scale for voluminous repetitive operations. Voluminous data can be stored, retrieved, and transferred within a fraction of a second. These technologies are user-friendly and provide ease in connectivity to a wider range of processing and controlling equipment. Some of the popular auto ID technologies that are commonly used in logistics are barcoding. Number one is barcoding. Barcodes are used for identification, handling, retrieval, and storage of goods in warehouses and stores. It is most popular identification technology in many applications. Individual inventory items, cartons, or unitized packages are affixed with a barcode that can be read by a barcode scanner attached to an online computer system. Barcode is assigned to a particular inventory item to show its identity during storage, retrieval, and dispatch. Barcodes are further used for communication of dispatch items, for the preparation of bills by accounts departments, and making periodic reports on inventory status and sales. The barcode facilitates the tracking of specific item in the warehouse during inventory audit or material pickup. They also help in tracking a consignment during transportation or inspection at the customer end. The information that may be required generally relates to the country code, manufacturer's name, product details, date of manufacture, material content, and so on. These details are required at the user's end for inventory management and are in machine-readable codes in the form of bars and spaces. Barcodes are seen on all types of goods today. It is a sequence of parallel lines of different thickness with spaces in between. These barcodes are nothing but items of information in coded form, which can be decoded or read with the help of a scanner. In other words, barcode is a type of Morse code to put information of an item in code language. The barcode facilitates data accuracy, real-time data availability, uniformity, and easy usage, which are recognized universally. The history of a barcode can be traced back to its first application in the US supermarket in 1952. This system was developed for automatic capture of product information at billing counters in supermarkets. In 1960s, it was used in food stores in United States on a trial basis. However, due to advancement in electronics and the formulation of universal product coding system, barcoding gained widespread acceptance in all supermarkets in the United States by 1974. Its usage in the manufacturing and service industries rapidly spread from 1980 onwards. In India, barcodes are used for limited applications by the limited companies. The pioneer in their use in India are Bajaj Auto Limited and Maruti Udyog Limited, both of whom are using barcoding at their manufacturing plants for the past many years. The barcodes have found application in such diverse areas as an automobile industry, logistics, retail chains, electronics, defense, pharmaceutical industry, banking, consumer goods, libraries, airlines, passports, and so on. Today, the barcode is invariably used in practically all industries. Barcodes increase productivity in three ways. First is speed, second is accuracy, and third is reliability. Besides, they offer the following advantage. First, they facilitate easy identification of inventory items during storage, retrieval, pickup, packaging, dispatch, transit, and inspection. Second, they reduce paperwork and processing time, leading to cost reduction. Third, they eliminate human error. Fourth, they increase the productivity of the warehouse. And fifth, they facilitate system automation. The barcodes are described by the symbologies used. Symbology means the pattern of lines and the spaces used within the barcode to represent a number or an alphabet. There are 260 symbologies available for different application for product recognition depending on the industry, business sector, and products. Several factors play a role in the selection of barcodes suitable for your operations. Most industries have defined their barcode symbologies based on the following factors. Number first is ease in usage of symbology in a particular product industry. Second is nature and type of data to be encoded. Third is information fields to be encoded. Fourth is feasibility of universal acceptability. And fifth is location and size of the code on the product or item. The various barcode symbologies differ both in the way they represent data and in the type of data they can encode. Some symbologies can encode numbers, while other both numbers and letters, and some can encode letters, numbers, as well as characters, that is ASCII codes. The latest symbologies include multiple language options. Barcode symbologies can be divided into three broad categories. Number one is linear. Linear symbologies consist of a single row of bars and can be read by a single line scanner. Number two is stacked. A stacked symbologies consist of several rows of bars and spaces and can be read by a multiple ID scanner with moving laser beam. And third is matrix. These symbologies are in a polygonal array of data cells and are read from a 2D image scanner. Barcodes are also 1, 2, or 3-dimensional types depending on the symbology and its application. The methodology in deciding the barcode is to study the requirement of the customer. The cost factor plays a major role in deciding what symbology to use. The typical application areas of a pre-printed barcode labels are high-volume industries such as retail chains, FMCG, automobile spare parts, and consumer durable industries. The second type of barcode label is prepared on demand in accordance with the needs. This is invariably used in order processing wherein a barcode is assigned to a particular order received from the customer. Orders from different customers are unique in variety and volume of the product items. During the entire processing, the order is recognized with the barcode assigned to it. On-demand barcodes On-demand barcodes are flexible, but the cost is high. Scanners are used for automatic identification of the barcode. The pattern of bars and spaces reflect the light pattern, which is converted into electronic signals to be decoded by the computer with reference to the memory file in the computer system. The choice of scanner is not dependent on the type of symbology in use. Two types of scanners are in use: contact scanner and non-contact scanner. Scanning devices operate at different distance, called depth of field, from barcode labels. Scanners with zero depth of field are called contact scanners. Also available are remote scanners with depth of field of several feet. The scanners that are used in the retail stores at the billing counters. Bills will be prepared and inventory updates will be done automatically for the items identified. This allows precise tracking of stock keeping unit sold and facilitates the quick replenishment of the same for communication to the suppliers. Thus, online tracking and replenishment of any number of SKUs without error is facilitated. In stores where the volumes of inventory handled is low, the contact scanners is in use. In libraries, for example, when books are issued and returned, the contact scanner is used for identification of the book title, author, subject, date of issue, and so on. For handling large volume of inventory, the non-contact scanners are used. However, the condition here is that stock or consignment has to pass through a fixed point onto the conveyor. Say if 1 lakh packs are to be handled per day, the non-contact scanner will be ideal to sort or consolidate the various inventory items for packaging and dispatching region-wise or customer-wise. EDI and barcoding can be linked together for improving the effectiveness of the system. For example, in case of an electronic order from the customer, the supplier can assign a barcode for that order, which will include the product, quantity, price, delivery, and so on. This information on barcode label can be scanned at the time of dispatch to generate such documents as a packaging list, invoice, bill of lading, excise gate pass, and advance shipping instructions to buyers. Invariably, the barcode technology is used in procurement, processing, and distribution operations in all industries. For system productivity improvement, barcode technology is widely used in modern warehousing and distribution operations in all industries. Today, the automobile industry and retail chains, where a wider variety of items with large volumes are handled under time constraint, are widely using the barcode technology. When parts and components are brought from suppliers, they are assigned barcodes, which contains information on the item's name, batch number, date of manufacturer, order number, serial number, and so on. This information in barcode form helps in identifying and tracking the part or item during its processing and further when it is in transit as a finished product to the customer. When goods enter through the conveyor in the warehouse, they are scanned either by a handheld or non-contact scanner fixed alongside the conveyor. The information decoded by the scanner is immediately logged in the central computer. This helps in real-time update of the inventory records. Automatic sorting of the item on the conveyor can also be done for directing them to the assigned storage place in the warehouse or to the packaging area for further dispatch to consumer located in different geographical areas. During order processing, the warehouse operator can prepare the order pickup slip confirming the location of the items to be picked up for packing to the forklift operator. The barcode will help in identifying the items based on their date of entry into the warehouse or store. This will ease material storage, retrieval, and dispatch in first in and first out inventory management system. In the case of box containers or pallets with barcode labels, it becomes easier to identify the content and check pack quantities without breaking open the cartons. In logistics, barcoding makes identification of a particular item or part meant for a particular customer easier. It is very helpful for the export units where detailed information on items has to be maintained for the excise department, customs, sales tax department, and export inspecting agencies. Barcoding eliminates a massive amount of paperwork and can avoid procedural delays in clearing the consignment. During the production process, the identification of in-process and finished items become easier because of barcoding. The various dispatches at different stages of manufacture can be easily tracked.